This is preparing for the ACT 2021-2022, the science section, passage 3. So in this one, what we're doing is we're looking at an experiment where we're tracking quite a lot of variables here. And so, first off, from the description, it says, we're studying the effects of pH and of nickel concentration. Those are the two experimental variables, or independent variables if you want to use the math term or statistics term. Now, what are the dependent variables? The dependent variables are, well, how does it affect plant growth? How does it uptake iron? And how does it uptake zinc? That's what we're doing. So we took seeds of species M and species U, so that's also another variable because we have different species. They were fed one of 12 different nutrient solutions, different amounts of pH, different amounts of nickel. And so table 1 shows the dry mass of the plants after they were harvested. Figure 1, that's this chart over here, it shows that for each species, the average iron content and the average zinc content of the plants that were fed solutions 1 through 4. So if I take a quick glance at this table 1 right here, I see, okay, solutions 1 through 4, they all have a high pH. And what they do is they differ by the amount of nickel. Solutions 5 through 8 have a middle pH, and then 9 through 12 have a low pH. But they all do the same thing when it comes to nickel. They all go from low, that is 0, to high. Now they told us that figure 1 shows for each species the average iron content that were fed solutions 1 through 4. So 1 through 4, all this information is up here in this chart. And so if we look, what's the measurement of, on the x-axis, the nickel concentration? So we start at 0, and then go to 5, and then 10, and then 15. So if I look at that, well, here's 0, 5, 10, and 15. Those are solutions 1, 2, 3, and 4. So that right there, that's all solution 1. This right here is all solution 2. This right here is all solution 3. And this right here, this is all solution 4. So let's see what we're being asked of. Number 15, according to figure 1, so we're looking at the graph, as the nickel concentration, all right, so let's stop right there because we got to keep track of what we're talking about. The nickel concentration increased, the average iron content, okay, so iron, so that means we're looking right here of which species? Species M, plants. So that means we're looking here. So we're looking at the filled in square. So that is this graph down here. That's what we're focused on. And so what did it do? It just decreased. So that's letter B. So that's what this one is saying. So number 16, according to table 1, the species U, so let's highlight that, plants that were fed a solution that had a pH of 6 and a nickel concentration of 10 micromolar. Okay, had an average dry mass of, all right, so let's go back to the table. All right, pH of 6, so that's these right here. Then it said a nickel concentration of 10. And then we wanted, oops, wrong color. Let's get the right color. And what we were talking about was we were talking about species U. So that means we are interested in this number right there. because we're asked for the average dry mass. Yep, that's the word, average dry mass. So we're asked for 8.1. So that's why letter G is the answer. Number 17, according to Table 1, species M plants that were fed, let's highlight these again. Here we're talking about species M. And we're asked for the highest, at the greatest average dry mass. So we're looking for species M, and where did they have the greatest dry mass in the table? So we're only looking right here, and the highest dry mass happens right here, and actually right here. It happens in two places. Now here's where you have to notice what your options are. So if I scroll back over, I notice that, well, it only gives me options for a pH of 6 or a pH of 5. So that means that this one is not even an option. So the only one is this one right here with a pH of 6 and a nickel concentration of 0. So that's why the answer is letter A. Number 18, according to Table and Figure 1, species M, so let's erase some of this. So we are focused on species M right now. Plants that were fed solution 3. All right, so here we're talking about solution 3, right there. Had an average zinc content of, all right. So we need the table to tell us which solution we have, and that is solution 3. And so now, going to our graph, again, solution 3, that's these numbers right in here. And so what we want is species M, the zinc concentration. So that is this right here. So that is the open square. So this is the point that I'm interested in. So I want to figure out, all right, how much is that? So I trace that over, and that gives me a value of 200. So that's why the answer was letter H. Number 19, according to Table 1, Figure 1, for species M plants that were fed solutions 1 through 4, what is the order of the nutrient solutions from the solution that resulted in the lowest average iron content to the highest average iron content? All right. So we want to go back and look at species M, iron. So here I want to look at the graph. And let's erase some of this. So species M for iron, well, that's this graph right here again. And we said that this was solution 1, this was solution 2, this was solution 3, and this was solution 4. And what we want to do is we want to put it in order from lowest to highest. So which one was the lowest? Well, that's this one first. That's number 4. Then this one, that's 3. Then this one, that's 2. And then that one, that's 1. 1 had the highest iron solution because that's the highest point on this graph. So the answer was 4, 3, 2, 1 in that order. Number 20. According to Table 1, compared to the average dry mass of species U plants that were fed solution 3, The average dry mass of species M plants that were fed solution 6 was approximately, okay, quite a lot here. So the average dry mass of species U plants that were fed solution 3. So let's go back, and then we're comparing that to the average dry mass of species M plants that were fed solution 6. All right, so solution 3. Here we've got solution 3 right there, and then we've got solution 6 down here. Now, what do we want to look at? Solution 3, we're looking at species U. Solution 6, we're looking at species M. So what we're doing is we're comparing 9.6 versus 28.8. And so it says compared to. So this right here, the 9.6 is our basis of comparison. And so the question is, how much bigger is 28.8? Well, it's bigger. So that means we can cross off letter F and letter G. Now, is it 2 times or is it 3 times as great? Now, here's an example where you don't really have to do precise math. Instead, all you have to do is just do some rounding. So 9.6 is close to 10. And 28.8 is close to 30. Does it have to be right? No, but that's why they have the word approximately in there. So approximately, it's about 3 times as great. So that's why the answer is letter J. Thanks for watching, and stay tuned for the next video.